Welcome to Uncle Online Academy. In this lesson, we want to look at the quiz we have on elasticity. So we are going to solve the quiz, and it's going to be an extension of our discussion on elasticity. In this first question, we have that a load of 15 Newton was suspended on a spring. It extended to 50 cm from its original length. Let's call the original length L. Now, an extra 5 Newton load was added to it, causing the length to extend further to 68 cm. Calculate the original length of the spring. Of course, we know that when we place a load on a spring, it will cause an extension or expansion of the spring, and when we remove it, it will bring about compression. Extension gives negative positive value, while compression brings about negative value. Now we have L as the original length of this material, and when we add 15 Newton to it, the length goes to 50 cm. So let us say that E1, we have F1, which is the first force. F1 is equal to 15 Newton, and this 15 Newton brings about the extended length minus the original length, which is equal to 50 minus L. This will give us the extension. The new length minus the original length gives us the extension. Now F2 is equal to, we already have 15 Newton on this object, and there's an extra 5 Newton on it, so everything becomes 20 Newton. Then the new length goes to 68 cm. Now we have E2, this is E1, then extension 2 is equal to 68 minus the original length, which is L. This is equal to E2. Now we have that F1 over F2 over E1 is equal to F2 over E2. Now this gives us that 15 over 50 minus L, which represents the first E, is equal to 20 over 68 minus L. That is the second E. Now we have that we do cross multiplication, and that gives us that 68 minus L times by 15 is equal to 50 minus L times by 20, and this gives us 58 times 68 times 15 will give us 1020 minus 15 times L will give us 15L. This is equal to 20 times 50 will give us 1000 and 20 times L will give us 20. Now we can now collect like terms. This is 15L. If we collect like terms, we have 1020. 1000, this is 20L. 1020 minus 1000, that is the ones without L, they will be together, is equal to, this is equal to 20 is there, minus 20, we have minus 20L plus 15L. Now this gives us that 20 is equal to 1020 minus 1000 gives us 20. This is equal to minus 20 plus 15. This gives us 5L. Now it simply means now that L is equal to 20 minus L minus L minus L, or let's say 20. L is equal to 20 divided by minus 5. Okay, so and this gives us that L is equal to minus 4 cm. Now L can be negative or positive depending on whether the force acting on it is bringing about compression or expansion. Compression or expansion, or the extension that happens in a spring. The spring can compress and it can extend or expand. So if the force acting on it had been acting on compression, then the original length will return back, which will give us negative. So the original length of the spring is negative 4. Remember that a string is something like, maybe you have this as a string here. So this could be a spring. So we could place a force here, bringing a compression on it, or it could be that if we turn this to this side and we hang a force on it, it will bring an extension of the wire or expansion of the wire. So it could be compression or extension or expansion of the spring. So our value is negative 4, which means that the original length of the spring will return back to 4 when the force is removed. Now let's look at example 2. In this example 2 here, or the question number 2 in the quiz, and example 7 here, we have that an elastic material of length 10 cm produces an extension of 2 cm when a load of 5 Newton hangs on it. Calculate the new length of the material when a load of 25 Newton is applied. Now to solve this, we bring out our parameters. Our F1 is equal to, when a load of 5 Newton is equal to 5 Newton, and our E1 is equal to an elastic material of length. This brings an extension of 2 cm. The extension on this 2 cm, we have the original length of it, and we have extension for the first one, which is E1 is 2 cm. We are not doing anything to get A1. The E1 is given to us directly. Now, calculate the new length of the material when a load of 25 Newton is applied. Now, what this means is F2, this is F1 is equal to 25, and E2 is equal to what? We are looking for E2. This is not actually the value we are looking for. Calculate the new length of the material when a load of 25 Newton is applied. When we get this extension, we add it to the original length, which is 10 cm. That is why this 10 cm is given to us, so that when we get the extension, this second extension, we add it to the original length and it will give us the new length of the material. Now, using that, F1 over E1 is equal to F2 over E2. Now, this gives us that 5 over 2 is equal to 25 over E2. Now, if we do cross multiplication and solve this, we are going to get that 50, or let's say 5E2 is equal to 50, and that means that E2 is equal to 50 over 5, and this gives us 10. Now, with this 10 we have here, it means that extension produced for this is 10, and then the new length is going to be the extension produced. This one alone is the extension produced when a load of 25 Newton is applied to the material. So the length itself is going to be the extension produced plus the original length of the material, which is now, original length is 10 cm, that is this, plus the extension we have, which is this, 10 plus 10 cm. So everything now is equal to 20 cm. So the original length, the extended length of the material when a load of 25 Newton is applied to it is 20 cm. Now, example 8 and question number 3 in the quiz. A spring was loaded with two pieces of iron rods weighing 19 Newton and 8 Newton respectively, causing its length to increase by 8.2 cm. If the length of the spring retracts to 10 to 40 cm when the smaller load is removed, calculate the original length of the spring. Of course, I said before that in a spring we can have a compression or expansion. That means when it is increasing or when it is retracting. In a spring, it is one feature of a spring. It can retract or extend when a force is applied to it, depending on how you applied the force. Now we have F1 here. F1 here, a load of a spring was loaded with two pieces of iron weighing 19 Newton and 8 Newton. F1 is equal to these two forces. They were placed on the spring on the same time. So we have 19 plus 8, which gives us 27 Newton. This is F1. They are two pieces of rods. So instead of placing one rod that weighs 28 Newton, we decided to place two, combine two, that two of them will give us 27. and place it on the spring. Now the extension produced is it is increased by this by means that this is the extension produced. So we have E1 already known. If you hear by, take that one as the extension and not the length. I've told you the difference between extension and length. So we have the E1 as 8.2. Now, if the length of the spring retracts, that is, it compresses now to 40 cm when the smaller load is removed. Which one is the smaller load? We have 19 Newton and 8 Newton. So we are now removing the 8 Newton, which is the smaller load. And when we remove it, the length of the material will come back to 40 cm. So we have that F2 is equal to 19 minus 8 is equal to 19 minus 8, which gives us 11, which gives us 11 Newton, right? Now, plus, okay, 11 Newton, and then E2 is try to this calculate the original length of the spring. Now, E2 is watts. Calculate the original length of the spring. E2 is watts. Now, E2 is going to be equal to the extension produced. The original length, it is going to be the original length, this extension, extended length minus the original length. That is going to be the E2. The extended length minus the original length. If the length is this, so we have it as the length now, E2 now is equal to the extended length is equal to 40 cm minus the original length, which is equal to L. So let's take L as the original length of the material. When we minus L from 40, it is going to give us the extension produced. Now this gives us that becomes our F1 over E1 is equal to F2 over E2. Now this gives us that F1 is 27 over E1 is 8.2 is equal to F2 is 11 over E2 is 40 minus L, 40 minus L. So we have now what we are going to have cross multiplication, and then we have that 27 brackets 40 minus L is equal to 8.2 times 11. 8.2 times 11. This gives us 27 times 40 will give us 1080, then minus 27L. This gives us 8.2 times by 11 will give us 90.2. 90.2. So we have now that we now have that 1080. We bring this one to this side minus 90.2 is equal to 27L. With that, we are now going to have okay 1080 minus 90.2, that gives us 989.8 is equal to 27L, and then our L now is equal to L is equal to 989.8 over 27, and this gives us 30 36.7. So this is the original length of the spring, 37.7. So what this actually shows is that the spring has been under extension or expansion. So that is why the value here gives us positive. So the original value or the original length of the spring is 37.4. So this is how to solve the questions, and I believe that you've seen that they are very easy to do, and it's very clear here. Thank you.